and Gas Engineering Council, MOGEC, together with Busch Malaysia Sendirian Berhad. I'm Tilak, the General Manager of Busch Malaysia, will be your facilitator for the next hour. So just, maybe some of you, we don't come across this term vacuum that often, right? So what is the first thing that comes to our mind when we hear the word vacuum, right? For some, it can be the vacuum cleaner that we use at home to clean the carpets, right? For others, it can be the image of a full space suited and floating on the surface of the moon. All these requires vacuum, a condition where the air pressure is lower than the atmospheric pressure, right? Similarly, vacuum pumps generate differential pressure at its inlet. In a nutshell, when a pump creates a lower pressure than the atmospheric pressure at the inlet, this we call a vacuum pump, right? So there's mainly three types of technology in the vacuum world. We call the dry technology, where the medium used by the vacuum pump to create the differential pressure is simply air. Second, the oil technology, where the pump uses oil to create the differential pressure. Sometimes we call the oil flooded vacuum pump. And third, the liquid ring vacuum technology, where the liquid, usually water, is used to create the differential pressure in the chamber of the pump. This we term as liquid ring vacuum pump. And today we gather here to talk about the liquid ring vacuum technology, specifically in the flare gas recovery application in oil and gas, both upstream and downstream. Also used extensively in chemical segment, petrochemical, oleochemical, and even plastics processing. To discuss this in depth, we will be joined by three of our panel speakers with ample of experience in the liquid ring vacuum technology and oil and gas segment. First, Mr. Craig Johnston, Global Market Development for the Energy Market at Busch. Over 20 years of working experience in the rotating equipment aligned to energy market. Mr. Johnston is responsible for overall energy market development within Busch. Second, we have Mr. Matthew White, Global Product Manager for Dolphin Liquid Ring Vacuum Pump and Compressors. Over 45 years of experience in liquid ring vacuum technology, Mr. White provides technical support, system selection advice, and Dolphin application training with particular focus in energy market segment. And finally, we have Mr. Peter Busch, our product manager for Dolphin LN3002 series liquid ring compressors used in oil and gas industry. With over 39 years of experience, Mr. Busch supports Busch sales entities globally in sales and technical application for Dolphin LN product series. We will commence the presentation for the next 45 minutes or so and open for Q&A in the last 15 minutes or so. So during the presentation, we remind our respective participants to mute their microphones. You may type your questions in the chat box and we will read out during the Q&A session later. Alternatively, you may unmute your mic at the Q&A session later to ask questions directly. So without further ado, I would like to invite Craig to start the presentation. Craig, over to you.
Yep, thanks very much for that, Tilak, and thanks for the introduction. So I'm happy here today to run through the first part of the presentation. So from my side, a quick introduction to Busch, just so you know who we are, both globally and from locally from Malaysia. A high-level overview of the flare gas recovery system, the application, and then I'll pass over to my colleague Peter Bucher, who will run through one type of technology we have for liquid ring, and then secondly pass over to my other colleague Matthew White, who will look at or give you an overview of another liquid ring technology we have that are aligned to flare gas recovery, but also to other oil and gas applications. They'll then pass back and I'll just have a quick summary and then we'll move to the questions. So I hope you all find it a little bit useful. So first of all, the company introduction. So Busch, we're still are a family business. We were formed in 1963 in the Black Forest in Germany. Still to this day, you can see the center of the picture, Dr. Busch with his wife, Frau Busch. They were the original founders of the company, and they're very much active in the business today. supported by their 2 sons and also their daughter. The Busch Group is formed of 3 companies now. Busch Vacuum Solutions is the part of the company that we represent here today. But now Pfeiffer Vacuum joined the Busch Group a few years ago, mainly for deep vacuum leak detection, and then just more recently Centrotherm, which covers the abatement side of our business. So the Busch Group now is effectively three companies. Just some quick figures of the size. So we're around 8,000 employees globally. We're all over the world, around about 44 countries, let's say, with 19 production sites. And I've just mentioned that we are now we comprise of three leading brands in the market. So just to concentrate a bit on the Busch side, just so you can see where we're based. Really all over the world, as I mentioned, with various companies in different countries, and also production sites that cover across the complete geographical spectrum. So we have a very extensive global network, and we always are local to our customer base. So we have a portfolio of 14 different types of technology, and we all have an individual name, let's say, for the different types of technology. So today we're here to talk about the Dolphin, which is our liquid ring vacuum pump and also overpressure technology. You'll see the bar down here on the left-hand side. So here is what T-Leg mentioned is atmospheric pressure. So everything below that is classed as vacuum, and everything above that is overpressure. So as you'll see, we have a vacuum side, and we also have the overpressure side. And each of these different technologies support various markets and also various applications. So we can cover generally every application and every market that we come across. So just a little bit on Busch Malaysia, T-Leg.
Yeah, thank you. Great. So Busch Malaysia is a wholly owned subsidiary of Busch Vacuum Solutions Germany. This distinguishes us from the distributors or resellers we normally see here representing a principal brand. So where our focus is not just to build inventory throughput or number of pumps, but we ensure customer after sales needs are catered at its best long after the purchase. This we do with multi-year service contracts with end users to ensure asset reliability is sustained. Busch was established back in 1998 in Malaysia, and in the last 26 years, we have been supporting our Malaysian customers in various segments, including oil and gas, electronics, semicon, chemical, plastics, pneumatic conveying, wastewater, and food segment. In oil and gas segment, Busch has been working close.
Move on to the application, which is what we're here for today, which is the flare gas recovery system. So I just want to run through a little bit of high-level information. I'm assuming we have a varied knowledge here on the call today, but let's start from the bottom and then work our way up. So what is flaring? So a flare gas or a gas flare is a flare stack, and ultimately it's a combustion device used in various process plants, and you're probably familiar. This is what they look like. So various process plants can be gas wells, refineries, oil and gas production upstream, downstream, and also moving into the chemical plants also. So everywhere where we have a process using waste gas, there's a potential for a flare gas system to be or a flaring stack to be in operation. The reason why we do flare, and this is a few reasons, but mainly safety. Okay, so we're protecting the sort of the pressure vessels that's on that production facility. So, you know, pipes or tanks, basically from over pressurizing, and this is generally due to any operational upsets that can occur on the production side. So the object of flare gas recovery systems, certainly globally, there's a move now to reduce the amount of flaring that's taking place. So it's called a near zero reduction. I don't think we'll ever stop everything 100%, but certainly a push to reduce it considerably. The reasons why, first and foremost, social and environmental issues. So we really want to reduce all of the plant emissions that are being just burnt into our atmosphere. And also around the area where these production facilities are, is to make sure that we're reducing, you know, sound and odor for the residents and so on that's around that area. Another great value is that this waste gas that's just been burnt previously, this can actually be retrieved and be used as a high heat value fuel source in the operation of the plant. So it has an actual value, which is probably what the customer is mainly looking for. And when you look at the value of retrieving this against the upfront capex of this equipment, there's definitely good profitability and a short-term return on investment for the customer. So when we look at some of the industrial requirements for the flare gas compressor, here you'll see a general overview schematic of what we mean by a flare gas system. I'll come on to that in a little bit, but certainly operation flexibility is key. A lot of these production facilities can have various upsets because of just the nature of the production. So you need a lot of flexibility. The inlet and discharge conditions can be varied also, depending on the flow and the type of gas that's coming into it, the temperature, and also the molecular weight of the gas composition. H2S will be relevant, so the system needs to have a good tolerance towards this very corrosive H2S. Very much so, the flare stacks are in generally a remote, unattended area of the plant. So the compressor needs to really have a high reliability and availability because of its remote area. Maintenance and operation costs are key also. So it's not just the capex that customers look at, it's also the opex. So the complete operational cost, let's say, of electricity and of maintenance of the equipment. And of course, we want to have a long equipment lifetime. We don't want early failures or constant maintenance of these units. So 3 main points, let's say, of why we want to choose a liquid ring for this type of application. I think I've already mentioned the first one, but you know, tolerance to liquid slugs, so large quantities of water, let's say, or hydrocarbons coming along the gas stream into the compressor. The type of technology needs to be able to withstand that. Low operational temperature. These are an isothermal unit, so you can probably understand in these types of applications, you don't want any heat or anything that generates heat because of the hazardous area. So these liquid ring compressors are isothermal units, and for sure, high reliability and low maintenance requirement is required. So very briefly, we have the flare gas coming into what we would call a knockout vessel. Okay, so any large slugs of water, let's say, would be taking out here. The gas then previously, if you let's say, discard this bit here, would have just gone straight down the pipe into the seal drum and then up to the flare stack and obviously burn just the atmosphere. And there's so many of these still in operation globally. Yeah. Now, if we add the compressor system, instead of the flare gas going into the flare stack and being burnt to atmosphere, it's now compressed, let's say in the gas compressor, and then this recovered gas is then sent to an amine scrubber where it's cleaned, and then the clean gas is then sent to wherever it will be used on the production plant. Just looking at sort of the detail of the compressor system, which is what we're here for today, on some of the main key points. So the operational principle, you've got the process gas flowing in from the header, okay, and then this is compressed into the compressor. It's then exhausted out into a three-phase separator. So this three-phase separator is separating the gas, the recovered flare gas that we're interested in. There'll also be a portion of the seal liquid. So the compressor here is sealed with fresh water, okay? And then also there'll be an element of hydrocarbons that's came through the gas stream that's also settled out. So it's a very important part of the overall system, the three-phase separator. Once the gas is settled and extracted out, as I mentioned, this is generally sent to an amine scrubber, which will clean the gas and then send it to the plant. The water that we use for the liquid ring, okay, this is generally on a closed loop circuit, but then with a makeup as well. We actually cool the water as well, so we always have a cool running compressor, generally done by a shell and tube type, but it can also be an air fin type also. And the overall material construction of the compressor system can be a carbon steel or a 316 stainless or alloy, manufactured to various requirements. It all depends on really what the composition of the flare gas is that's coming into the unit. Sorry about that picture. It might not come through as clear as I hoped, but really the picture is showing you a typical P&ID for 100% liquid ring compressor, which is here. I'm sorry if you cannot see it. Also the three-phase separator, which I mentioned on the previous slide, and also the shell and tube type liquid cooler. This is, let's say, a standard, if there is such a thing as a standard, but a standard system. So each system has various requirements, and these are always dictated by the engineering company or the end user that's responsible for the overall project. But some things that we generally go through, you can see here on the left-hand side, the various codes depending on what it needs to be manufactured to. Generally API is one, but various other codes for the vessel and so on. The gas handled, we need to know that, what hydrocarbons in there, H2. So basically the overall gas composition, so we can select the right size unit. Also that helps. Peter?
Yep. So take over the controls. So first of all, we have an overview about the sizes. And here we see about what do we handle in our compressor. So we start here from the discharge. That's the discharge pressure from 1 bar ambient up to the 10 bar absolute. And here we have the volume flow. From the volume flow, you see we have the different sizes we can use. So we have big pumps, big compressors in the volume. This goes only to 2.5 bar. Most in the flare gas application, we have higher pressures up to 6-7 bar. Here we have the LN type, which goes up to 10 bar. and volume flow is about 2,000–3,000 cubic meter an hour. So that's the blue line. We also have the LB types. And we see the difference of the LN and LB types later on in the details. This goes also to a high pressure, about 4 bar, and with higher or lower volume flow. So mainly we can focus on the flare gas recovery on the higher pressure side here, while if you need lower pressures, we can have also bigger volumes. Now let's look on one certain type, that's the LN type of the liquid ring compressors. First, we have about the dimension. This is a quite medium-sized compressor. It's not very light. This is the example for a one-stage compressor. You see later on how it is built. You see it's quite heavy, especially we have 3.5 tons on this unit. We have here the shaft on one side and the connections on the left side. The same for a double stage machine. So here we have first, second stage, also the motor on one side and all the connections for the process line on the other side, on the head side. Be careful because this unit is quite heavy. We have to use about a 5-ton cranes because it's nearly 4 tons, the bare shaft unit without the motor. Now, how does it work? The difference from the LN type to other vacuum near types is the location of the impeller. As you see, the liquid ring pumps, they are using a liquid ring, normally water, going around and following the shape of the casing. Here, the difference of the LN type is that the impeller is in the center of the casing. Vacuum pumps always have the impeller located eccentrically to have another kind of compression. So if you locate it in the center, you have a good compressor, while for vacuum pumps, you should have it eccentrically located to have a better moving of, let's say, the vacuum. The difference you see here. We have the suction going from the top into the head. Then we go in a part we called distributor because it distributes all the gases. It comes with a yellow arrow here into the distributor, goes into the impeller on the bottom and on the top. So we have a two-side suction in each part of the centric impeller. And then the impeller turns 90 degrees and the water gives the power like a piston, pushes the gas then back into the distributor. You see the green arrows. Here it goes then out horizontally back to the head and pushed out a part of the water and all the gas out of the nozzle here. So you see, we have a 2 times suction on each side of a centric located impeller, and on each side pushed out the gas. And you see why it is a good compressor. When you have it centrically, you have a 2 times compression, which has a compensated force of the compression power. So it means that even if you have a very high pressure, the impeller is not moved away by the pressure. The pressure comes from both sides. So you have a neutralized force because it's coming from the opposite. You have the force of generating the movement of the water. This is a big force you have to spend from the motor into the water. Then we look how is going the double stage machine. From a double stage machine, we have then this. Yeah. From a double stage, we have the suction also from the arrow, the yellow arrow. It goes directly into the first stage, like in the example before. It goes up vertically into the impeller.
The production of liquid ring vacuum pumps and compressors. My main responsibility in the presentation, my part in the presentation today, I'd like to present to you our conventional flat port plate design liquid ring vacuum pumps and compressors. So similar principle and the same principle liquid ring technology as the Dolphin LN compressors, which were presented to you today by Peter. Our Dolphin LA and LB liquid ring vacuum pumps and low pressure compressors are single acting with flat port plate. So a more simple design, but a very robust design, which has been in the industry for many years. Liquid ring technology was developed more than 100 years ago. And it's been used in the chemical and petrochemical industries as a workhorse for vacuum and low pressure compression for many, many decades. We've been producing this type of vacuum pump technology and compressor technology for more than 50 years here in the UK. We've got many years of experience, and what I'd like to do is to give you an overview of the range and some of the applications, not only flare gas recovery, but just to give you an indication of where this product type is used in especially petrochemical industry. So we have a range of 35 models, which consist of both single stage, what we call the Dolphin LA, with an end pressure of approximately 130 millibar, and the Dolphin LB two-stage. So similar to the Dolphin LN, we have single and two-stage. And as a vacuum pump, the two-stage have a typical end pressure of 33 millibar, and the same machine operating as a low-pressure compressor, also able to compress up to approximately between 2 and 3 bar overpressure. So that's up to 4 bar absolute. In terms of suction capacity, we have a range of 35 models covering 50 up to just over 5,000 cubic meters per hour. All of those pumps available in a wide range of materials, which I'll show to you separately in a moment. Shaft sealing is especially critical in the petrochemical industry. We need to offer a product which guarantees, in some cases, no leakage if we're pumping dangerous and difficult toxic gases, for example. So we have many options of shaft seals, including API 682, liquid barrier and gas barrier seals. We can offer all of the products with a choice of process flange connections to suit your needs in the industry, whether it's the DIN or the ANSI flange connection standards, and also welded connections such as the welded drain and liquid connection to the vacuum pump or compressor, where we have, for example, H2S in the gas stream, and we need to guarantee no leakage. We offer our products in compliance with the second edition of API 681, which I'm sure most of you will be familiar with. And we also have the Saudi Aramco 9Com certification for both the liquid ring vacuum pumps and compressors, but also systems built by our Busch systems company in the Netherlands. We offer all the products with ATEX certification as necessary. That's a standard offering for the Dolphin range of liquid ring pumps. The benefits to you in the industry, it's a proven technology, as I mentioned, backed by more than 50 years experience. We test all of our products 100% to the HEI and API standards or the NEUROP standards for liquid ring vacuum pump and compressor performance and tolerance acceptance criteria. We offer a full complement of testing and documentation. So all products, all materials will be certified to level 3.1 or 3.2. All the impellers are balanced, and we can offer certification for that balancing and any other non-destructive testing, NORSOC material compliance, and so on. We can offer the pumps with project-specific motors. So if your engineering standards and specifications are written in specific motors or shaft sealing or bearing lubrication options, we can offer all of that flexibility. Our products made here in the UK, we're a production company selling out through the Busch network of sales and systems companies, and Dolphin liquid ring pumps are an ideal solution and offer the heart of really good high integrity systems in these projects. We also offer combi systems within the group, whether it's with a Roots booster vacuum pump as a 4-pump, or a gas or air ejector, for example, for lower pressure achievement. And we have a lot of application and process knowledge within the group to support you as necessary. Applications for our Dolphin LA and LB, which it includes the application we're looking at today, which is the flare gas compression and recovery. But in oil and gas, we've got years, many decades of experience in seawater deaeration, for example, in crude oil distillation, supporting steam ejectors on refineries, also MEG and TEG regeneration, which was mentioned by T-Leg earlier, and any other gas boosting applications. So just to repeat that Dolphin LA and LB pumps are not only vacuum pumps, a vacuum pump can also operate with up to 2-bar differential pressure. So we can achieve both vacuum on the inlet side and overpressure where necessary if your process is pumping out to a treatment system, a scrubber or a vent, where we need to achieve and maintain an overpressure on the exhaust side of the vacuum pump. And liquid ring pumps are quite ideal for that application. Chemical and pharma, typical for liquid ring pumps, it's all the wet processes and more challenging processes of drying and evaporation, where the pump acts as a condenser and will condense the vapors and offer the benefit of volume reduction. In the power sector, we help to support steam turbine condensers in evacuation and holding the pressure needed in a turbine condenser. And in the petrochemical, as I mentioned, which is, I'm guessing, most important to most of our attendees today, we offer liquid ring systems for vapor recovery, for flare gas compression, which is the main topic of today's presentation, but also many other production processes, benzene recovery and solvent extraction. In terms of the materials, I mentioned the flexibility. We can offer almost any metal to suit the process, so we need to consider corrosion resistance in many cases, or mechanical strength. So we can have the start of any of the black materials, such as the basic cast iron or ductile iron for higher mechanical strength and pressure resistance, also carbon steel for refinery service. But when we need to offer and consider corrosion resistance, we can offer any of the stainless steel alloys, such as the standard 316 stainless steel, super duplex stainless steel, which we're seeing more and more in the chemical and petrochemical, originally developed for seawater. So that's our most common material now, either super duplex stainless steel or nickel aluminium bronze for seawater deaeration or deoxygenation. And we have many hundreds of pumps installed globally on that application. But also then we move up to very high corrosion resistant materials, such as Hastelloys and also titanium. So almost any metal which is suitable for your process. In terms of shaft sealing, we need to guarantee leak-free machinery on your processes. And that can be either single, very simple, internally mounted component shaft seals,